23rd question. Arterial blood extract from a healthy adult showed an oxygen partial pressure value of 40 mmHg. Total oxygen content in the arterial blood measured in percentage volume by volume as dash, rounded off to 1 decimal place. Given solubility of oxygen in blood, okay, hemoglobin oxygen saturation, oxygen carrying capacity of hemoglobin, arterial blood hemoglobin concentration. Okay, so we are given partial pressure of oxygen, solubility of oxygen, saturation of oxygen and hemoglobin, then oxygen carrying capacity of hemoglobin and hemoglobin concentration. We want the oxygen content in the arterial blood. Okay, so at this point notice for pressures I use P, okay, the subscript notes arterial. If it's A it's arterial, if it's V it's venous. And S implies saturation, okay, C implies concentration. So this is concentration of oxygen in the arterial blood, okay, arterial oxygen content, okay. So that is essentially the amount of oxygen that is there in the hemoglobin, right? If you look at the O2 carrying capacity of hemoglobin, it's 1.34 ml per gram. So per gram it's 1.34, okay, and there are 15 grams of hemoglobin in the blood, and it's 95% efficient, okay. So this is the amount of oxygen in the blood, right? So this value turns out to be 19.095, okay, and this value is incorrect. This is a trap because this is what is known as the bound oxygen content. So take the oxygen content, the bound part of it is essentially this. The total oxygen content in the arterial blood is a sum of two terms. It has this term, okay, then plus the amount of oxygen that is dissolved in the blood, that is CdO2. Okay, what is the amount of oxygen that's dissolved in the blood? Per mmHg, there is 0.003 ml per dl of oxygen. Okay, so in 40 mmHg, we have an additional plus. So the CdO2 term here is 0.003 per mmHg, that times 40. Okay, so this value turns out to be 0.12, and the sum of these two terms are 19.215, and this is in ml per dl, and rounded off to 1 decimal place, the correct answer is 19.2. okay, notice if we were to use just the bound oxygen content, okay, it's incorrect. We need to add the dissolved oxygen content to this. Finally, for the common session, try to answer why ml per dl is in, percentage volume by volume. Try to answer that in the comment section. I'll see you with another video. Good luck.